Hello students, welcome to class. In this session I will discuss the concept based on the finite automata. Okay, what is a finite automata? So finite automata is a, let me write the things along with that. Finite automata is a machine, or you can say a model, which are used to recognize patterns. Okay, means finite automata will recognize the pattern. How it will identify or recognize the pattern? By taking the string of symbols as the input, and with some desired operations. After performing those operations, if the pattern matches, it will give the output, otherwise it will reject. So how is that possible? See, suppose there is a finite automata. In this, some sequence of strings as were given as input. Sequence of strings were given as an input. Okay, here some operations were performed, and from these operations, if it will match, then it will give the output, otherwise it will halt or it will reject. Fine. So this is about the finite automata. Then what are the different types of automata were there? So automata are of two types. Automatas were of two types. One is with output, and automata designed without output. Okay, so the automata with output is also categorized in the two forms. They are Mealy machine and Murray machine. And if we talk about the automata without output, then they are classified into two forms. They are deterministic finite automata, DFA, and non-deterministic finite automata, they are NFA. So we will discuss each and everything in a detail. First we will start with the DFA, that what is deterministic finite automata. Okay, so what is deterministic finite automata, or I can write it as DFA. DFA represents deterministic finite automata. So before we discuss all these things, let me give you a technical definition of automata. That what is automata? How you define automata? Okay, so a finite automata is a collection of five tuples. Okay, what are those tuples? They are capital Q, comma, sigma, comma, del, Q naught, and F, that is final state. Okay, so what does these tuple signifies? See, if we talk about Q, then Q is a finite set of states. Okay, then what is a sigma? As I told you in the beginning of the session, that in the first session video session, that sigma represents the alphabet which contains the symbols. Okay, so what does sigma represent? Sigma represents finite set of input symbols. Input symbols. Okay. Then what does Q naught represent? Q naught represents initial state. And what does del represent? That I will tell you at last. Before that, I will tell what does F represents. F represents final state. Final state. Okay. Now the thing which is left is delta. So what does this del represents? Okay. This del is called transition function. This del is called transition function. Okay, so what does this transition function do? This transition function performs the operation or transitions between the two things. What are they? They are Q cross sigma. Okay, between these two, the transitions were performed. What is Q? Q is states, and what is sigma? Sigma is set of inputs. Set of inputs. Okay, so what is the role of these all the different kind of tuples? Okay, we will discuss all these things in the coming session with some examples. Okay. Okay, so one more thing is that whenever if the questions will come in the objective form, then they may ask that how many tuples are there in the automata. So you can say that there are five tuples, and since they have a five tuples, they are also called tranquil. Okay, since these have a five tuples, so these are called, these five tuples, set of five tuples are called quintuple. Quin quintuple. Okay, so these are the few points related to the finite automata. Now in the next session we will discuss about the DFA and NFA, and we will do some numerical based questions or problem statement based questions. Till that time, thank you to all.